He is.
Maybe he's not quite
Okay, maybe the network
right.
is not
Yeah,
strong. Just go ahead.
we'll go ahead. So I like to think that everybody can program, because every human being, we all have logical steps that we take just to live and go through life, isn't it? I mean, when you wake up in the morning, there are certain steps you take to prepare for your day. And a lot of times, there are things you must do before you leave the house to go to work or to school or to wherever you need to go. And one of the things that determine what our day looks like is whether it's a weekday or a work day. So if it's a weekday, you have a certain number of things that sort of fill up your day, activities that fill up your day. If it's a weekend, again, so at the beginning of your day, it's almost like you're making a decision how to approach the day based on whether it's a Monday to Friday or weekend, depending on where you are and what weekends are observed. Am I correct? I want it to be an interactive section. So, sorry, Ugo, it might be a bit chaotic, and but I like to interact and make sure people are coming,
Please
following.
fire away, ma'am. Fire away.
Yeah, yeah. So, Omo, if I can abbreviate your name again to even a shorter form, could what I'm saying, does that make sense to you?
Yes, it makes perfect sense. And yes, you can abbreviate my name. Thank you.
Right. You have to seek permissions these days. And what we do in programming is basically instructing the computer in very logical sequence how to process a piece of problem and resolve it. That's exactly what we're doing. And I will go with Omo again. And any of the men, in fact, men cook a lot of cooking competitions, men win it. So a lot of men cook very well. So when you're cooking or you're baking or you're cooking something you've never made before, who can tell me something that is very important if you're going to make that food to come out the way the experts make it? What is that piece of information that you must have? Anybody?
A recipe.
That's it, my dear. And what does the recipe tell us? Aziz, can you help me out with the recipe? What does it tell us? Aziz, unmute and let's interact. What's going on here? Aziz, are you out? Okay, Efe, could you help me out here?
I'm sorry, I'm here. I'm here.
Please, this is not, even if I'm going to do 30 minutes with you, I want it to be very lively. I want us to interact. I want us to get something out of the lesson. So what's the important thing the recipe does for us?
Uh, I'm, I think I think everything depends on the recipe determines whatever taste we'll get out of whatever we are doing. I'm not
No,
sure
but
I
when
might
you
have.
look at a recipe, don't make it complicated. I like simple solutions. Okay, I didn't really introduce myself and what I do, but one of my titles at work, sometimes it's called solution architect, right? So I like providing solutions, and the simpler the better, even if the problem is complex. What does the recipe tell us? FA, just in simple layman term. I'm not looking for any PhD level. Aziz was taking it higher. So just tell me, very basic FA. What does the recipe tell us?
Probably the method on the expected outcome. I don't know, something like that.
Yeah, the recipe just basically tells you the steps you should use in mixing whatever condiments you're
Whatever
going
you're
to.
going to do, Ugo,
Yeah.
I'm going to buy you from interjecting unless when I call you, because I
Okay, I'm
want you guys to
sorry.
take it. Programming is as simple as what Ugo has said. I wasn't trying to catch you out. All the recipe will tell you is the steps, the ingredients, the quantity of it. And if you follow it as they've specified, the expected result is exactly what the expert has produced time and time again. Is that not so? Right? Agree or disagree, somebody?
True,
Agree.
that's true.
Agree.
Omo, yeah. So the recipe now, Omo, sometimes you're looking at a recipe and you find that they've missed a step. Have you ever seen something like that? Or even, I'm not even, see, I'm giving you a description of coming to my house, right? And I gave you a very good description, but I omit one junction that you need to turn right. Are you going to get to my house easily?
No, I'll get lost.
Isn't it?
Yeah.
It's very logical. So the same way that, there are some people who are very good at giving directions, right? When they give you a direction to go to a place, you just follow that direction, and I'm not talking the ladies in the car that talk to us. I'm talking about, human beings. Some people are bad at giving directions. A friend of mine will always say, just go straight. When you're on the road, you see that it's winding and there are many, it's not straight actually. And by the time I get there, I tell her, no, your direction is rubbish. What is go straight when I had to take a right turn? Do you get what I'm saying? So the computer, just like the address of the recipe, expects you to give it stepwise instruction, just stepwise instruction how to get to, to the solution you want. That's what programming is all about. And it doesn't matter the language, it doesn't matter the platform, it's the same principle. You have to give the computer step-by-step instruction of what to do. So I just wanted to come at that level because I looked at what Guyot had done, all the codes there, and I felt if I'm new to programming, this is going to be so scary. There's nothing to be scared about in programming. It's actually quite interesting because all you're doing is describing to the computer, you know how to solve the problem. You are now describing it to the computer. And the only reason we ask the computer to do it is because it will become tedious if we have to do it every single time. Is it Omar that said she's a tax accountant or something? Was that what you said?
Yes.
Or banker? Yeah. There are things that if you keep doing it, it's so brain draining, isn't it? You're summing rows and rows of columns. What is one of the things that is inevitable if you have, rows and rows, millions of rows of columns and you're summing it manually? What is inevitable in that process?
It's a tiring process that you get exhausted.
Apart from that, are you going to get accurate results?
You might get
It's inevitable, isn't it?
Yeah.
It's inevitable. You're going to skip some places. You're going to not see clearly because after some time, you just get tired. So we give these instructions to the computer because the computer wouldn't get tired like we do, and it doesn't have that scope for error, right? And that is the reason and it does it faster actually, to do it faster. So the time you spend programming, and I'm doing this general introduction, pardon me for those who are, experts who've done programming, but for the benefit of any person who is totally new, I'm just giving this background. So what you just do is that the effort is going to take you is to write a piece of program once and you execute it all the time. And just like I said, a recipe could be a sort of program because once you've written it once, then anybody can replicate it. I know my children, they tell me, Mom, Nigerian food, they don't have recipe for it because they ask me, I'll say, put a little water in the pot, put some oil. I don't know if you can relate. And they go, how am I supposed to know what quantity of water and what quantity of oil is little? I said, well, some of this food you have to sort of do it and see as it goes. But computer doesn't behave that way. You have to be very precise, very accurate, and very stepwise. If you miss one step of the instruction, the computer will remind you that you missed it. Is it making sense so far, Omo?
Yes, it is.
Yeah? Okay. And again, apologies to people who I'm telling what they already know, but I was told this introduction to programming, so I'm taking it in this sort of direction. So I mean, I didn't watch all the classes you've had before. And if someone can just give me, I know I watched the first two. I've seen what the first one, I think Thumb did, showed a few things. The second one, Gart showed 2 games, if I'm not mistaken. Am I right?
Absolutely correct.
Yeah, but I didn't watch the third and the fourth or any other thing in between. I didn't have the time. I was trying to do all of that last night and I couldn't fit it all in. I just want to understand what you know what you've understood so far, because today I'm just going to be talking about how you navigate or how the computer navigates through your program. You know, so if someone I know, so as I said, I've seen the choose a number, random number game Gard did, and I saw the one of lining up X's and zeros or something like that, if I remember correctly, that he did. Right? I'm right. Yeah, those were the 2 games I saw. I don't know, Ugo, could you give me the other 2? What did you do? And so that I can build on that foundation.
Okay, basically that's all. The previous week we had Kuyen Tran. Kuyen talked about she talked about functions and variables, how to
Right.
create variables here, the naming conventions in Python, and then functions, how to create functions. Then she talked a bit about functional programming, how to,
Right.
yeah, so that's just basically what it's been.
Right. So have they started doing practice sessions and trying out what some of
Yes.
these things? Yeah. Okay.
Yes, we're supposed to have a couple of sessions, but I'm still waiting on Guy to send in this stuff. So I'm trying to make a pull request for that on his GitHub so that we can get that information.
All right. Okay. So that I can pull some of the, right. Okay. So that's fine. So today I'm just going to look at, normally just like the recipe, the recipe, when they list this instructions in a recipe and the number it, you sort of assume is going to go, in that order, and you follow it stepwise that way, right? In some recipes, there are certain things that you sort of need to branch off to go and do. I don't know why I'm talking about food today. Sorry, everybody. I didn't really plan to use food and recipes. If I make you hungry, apologies. Maybe, maybe because it's almost lunchtime. Anyway, but sometimes I dabble into baking. I've got children, birthdays and stuff. But sometimes you're baking or you're cooking. Oh, my Nigerian guys, if you're making, yeah, I think we're all Nigerians here, right? Right? Is there nobody else? Yeah, somebody's left.
No, Aziz will come back. He too has network issues.
Oh, okay. No worries.
It seems like it's raining everywhere apart from in Nigeria.
It's raining here as well.
It's raining there too. Right.
Yep.
Okay.
Yeah. So it's someone Efe. So Omo will relate Efe. I'm sorry if I'm using something. Yeah, I hope you cook. Cooking is not a gender thing. Efe is a man, isn't it? Yeah. It's not a gender thing. And so sometimes when you're cooking, there are certain things you sort of branch off to go and do, because assuming you are how should I say it? If I'm making a pot of stew, for instance, and a fish stew, for instance, and I've prepared my tomato and I've started boiling it, I will get to a point where I go and prepare the fish and season it, or vice versa, and then set it aside, and then come back to the tomato and perhaps start frying the tomato and seasoning it, and then go and bring the fish from wherever I left it to add into it. Again, don't know why I'm using food, but bear with me. I'm trying to make sure you don't forget this lesson, even if all it does is make you feel hungry. So in programming, the computer expects that when you start your coding, it's just going to read left to right and execute things as they go, unless you tell it to do otherwise. Am I making sense?
Absolutely.
Guys, unmute yourself. Yeah, I'll make sense to you. I'm asking on one Efe.
Yes.
Yeah. So, I mean, so the computer expects that whatever you've written, even if it's 3 pages of code you've written, is expecting to go from the top to the end. But as I said, just like when you're cooking, you start maybe, doing something, but you need to stop and go and prep something else, keep it aside and come back to your thing. So again, if you have a requirement to do that, and if you were going to instruct the computer to make your stew sauce, for your rice, you have to tell it how and where it should go off to prep something and come back and continue. And that is, every program does that. Life does that. But what we do in programming is learn the language and the technique for applying such logical steps in that programming language, right? In the codes that you've seen so far, I mean, there are certain things that are familiar to you. I'm going to take them in bits because, as I said, I listened to the first one and it looks like a lot of things going on. I'll try and break them down in small bits and take them one after the other. Does that make sense?
Yes.
Yes.
If is just, okay, I was going to ask you, what have I done? Right. So there are a number of ways that we pass control in Python and in every programming language, in the sense that you want the computer, instead of going sequentially from top to bottom, if I have 3,000 lines of code, instead of going left to right, top to bottom, you want it to get to a point where you redirect it, maybe from line 50, you want it to quickly get to line 2,000, do something there and come back to line 50 and carry on from 51. You can do that, so some of the things that they've shown you already, the functions are part of how you can package your bits of things to do. Just like I said, your boiling rice on one side, that could be one function. You're prepping the tomato sauce, that's another function. You're prepping your fish, that's another function. But at a certain point in the prepping of the tomato sauce, you are going to call the fish and bring it into that tomato sauce function, execute it, and take the output from it, as in add I don't know what examples I'm using, but Ugo, pardon me, and add it to your tomato sauce, and then that's how you complete your sauce. So, and that's just the simple and short of what we do in programming. So some of the ways that we do all this passing control is executing, asking the computer to make a decision. And one way of making a decision is the if statement. So the if statement is something that you're going to do one or the other. So it's always like a binary thing. It's either true or false. So if, it's like saying, if it's raining and I'm going out, I need an umbrella. Otherwise, maybe I need sunglasses or something like that. So it's unlikely that it's raining and at the same time the sun is shining. That's not normal. So if statements sort of tend to execute one or the other, the opposite condition. Now, don't get me wrong. It's also possible to have some finer details of the broad if. You have an if condition, if it's raining, and you might also say if it's raining and it's cold, making it, narrowing it down. Do I need an umbrella and also a jacket or something? I mean, back home in Nigeria, sometimes it rains and it's actually still hot. Sometimes it rains and it's cold. So you might, start looking at nested ifs, as we call them, where you're evaluating a condition can be true, but you evaluate other conditions under it, which may also be true or false, and you carry on that way. Another way that you can make a decision is to use the case. It's not a very common method or statement in Python, but it does exist. I will go through the normal ones, and then if we have the time, we can go into the ones that are not very common. But if statement is something that you would definitely, regardless, it doesn't matter how small a program you're doing, and if it's likely to find its way into it, because there is always decisions to make and actions to take based on the decision. Am I making sense so far, Mo?
Yes.
Yeah. So, Efe, did you say you've done some programming in the past? You do C#, did you say?
Yes, I have.
Right. So what I'm saying is not news to you then.
No, it's not.
It's not. Apologies, but I think for almost sake, let's take it
No,
in
it's
that
fine.
way. Yeah. Okay. Because what you do in C# actually, and in other programming languages, all you need to do for Python is find out what's the syntax, how do you do it in this specific language. But the broad concept is the same across all programming languages. If it's always a statement to execute a decision and to carry out actions based on those conditions, if they are true or false, right? So one way of looking at it is you can have a very simple if statement that doesn't even have a flip side, because you don't want to, you only want it to take that action if a particular condition is met. If that condition is not met, you just move on, basically. And what happens in Python and in programming is that if you have an if statement, so if it says, if I'm female, whatever I have under that if statement, and the syntax in Python is that when you have that if or any of those statements, you close it with a colon, and it will indent what conditions you're having under it. And everything that is indented is part of that if statement. Those are the actions you want it to take. Once you move out of that indentation, give it a space, move out, or invoke a break by specific methods or ways of invoking and escaping or removing or moving away from that condition, you've broken it. So if I have an if and I put the colon at the end, whatever I have that is indented at the same level of indentation are all a group of statements under that if, and they will execute under that if as one command. If I have another if under it with a further indentation, and I have other commands under it further indented, again, that is telling me that that's another body of commands I need to execute together. So that's how you sort of manage your control, because once you indent it works for every other thing, whether you're defining a function or a while loop, whatever else you're doing. Whenever you have a set of a command and you've put the colon at the end and you've indented a set of other statements under it, all of those statements are assumed to be part of the statement that you had the colon at the top. Omo, I'm using you as my reference. Is it all making sense?
Yes, it's making sense. Thank you.
Yeah, I will show a few examples, but again, I like to think that I've been successful in teaching programming to novices and people at different levels, because I try to make it as simple as I can, so that and everybody can understand the concept. And because understanding the concept is, for me, the basis, and then you can build complexities on that. Is that okay, everybody?
Yes,
Yes.
thank you.
Yeah, please. If it's too basic, apologies, but that's my approach to teaching, because I think it's important to understand. And again, we have someone who is not really, doesn't have a lot of experience. So if I'm dragging you back, just apologies. Let's bear with ourselves so that we can come to the same level. So that is one thing with the if. And if is so versatile because it allows you, as I said, to take decisions. And in every single thing you do, you are taking a decision to go right or left. And as we talked about, someone giving you a direction. So even when we talk, we say if you get to a junction, a T junction, take right. Or I say if you get to a junction, and if the junction in the UK, we say things like junction 11, take right. So you can have an if, which you now try to make a bit more robust by using different operators. So we can use what I've just done now, the and. We can use the or inside that if statement just to make it a bit more specific to whatever it is we're trying to ascertain. Because there are certain conditions, you don't want to leave it too broad because it doesn't make any sense, if you have only that single condition, because there are, there are too many possibilities. So you could have an and or an or with another thing. So you could say if it's a junction and it's junction 11, as I just said, then take right. Again, remember, for the computer, we must give it stepwise instructions. So you make it every single step of the way, you are instructing the computer on what to do. So another thing you can do with the if statement is actually to have a comparison operator where you are comparing a value with another. It's like saying if A is again, you've talked about variables before. Again, before, if I'm going to use variables in this instance, I would have substantiated it or declared it, ahead of using it. If you don't, Python will tell you about it, and every other language will tell you about it. So you can, inside the if statement, you can declare a variable and substantiate it, but you would have to do it, either before or inside the if statement. But what I'm saying is that if I want to compare, then there are if I'm saying something like greater than or equal to, then I'm using I'm using integers to determine whether something is greater than something or equal to it or less than it or greater or equal to. But those are things that you can validate because you have absolute numbers that would, because you can't say if or more is greater than, because it doesn't make any sense. Am I correct?
Yeah. No, I can't hear you.
Wow.
Okay, I can hear you now.
You can hear me now.
It froze for a while. It wasn't your headset. It just froze.
Oh, it froze. I see.
Yeah.
That's why I
okay.
like interactions. I was talking away. So I don't know at what point you stopped hearing me. I had talked about using the and to.
I think from here, I lost you at when you say you cannot use Omaye as greater than or something.
Okay, that was, so I said that, it doesn't make sense to compare things that are not absolute values like integers and co and use greater than for them. Does it make sense? Like saying if Aziz is greater than Efe. The computer will wonder, what are you talking about? How is Aziz greater than Efe? We can say, if it's my age, my weight, we can use weights of people, or, because it's quantifiable. I don't know if you get what I'm saying. So when you have string values or stuff like that, then you're going to. So what I'm trying to say is that when you're using your operators, you have to be mindful of what you're comparing so that it makes sense. Have you lost me again, or am I communicating?
No, we can hear you.
Yeah. So I can say if 2 is greater than 1, right?
Yes.
Because it can be compared, right? But there are certain comparisons that you can't use. That sort of operations on arithmetic operations wouldn't work on, say, if I put Ngozi greater than Omo. The computer and you would wonder what exactly does she mean, isn't it?
Right.
Right. So when you're using your comparisons, you have to be mindful of what you're comparing, because sometimes, especially when you're passing variables, is you might, and I'm talking as you go on, you start writing code and it start giving you some, having a wobble, and you wonder what's going on, because it's not comparing whatever you are comparing. It's not comparing the variables. You have to look at what values are you passing into those variables, and what operators are using to do the comparison, for instance. Because if there are string variables and you're doing greater than or equal to, you have to be mindful, because the computer will wonder, how do I know if that is greater than this, right? Please just communicate, because I don't know, this connection today is
yes.
I'm sorry if I'm being very demanding. It's just so
no, of course it's
we
right.
can address when things are going not right. So the other thing we also do, and Ugo, can you allow me to share my screen so that I'll look at some of the examples?
Oh, I thought I did that already. So just a second.
It's okay. No worries.
Done.
Thank you. Right. I made some notes which I'm happy to share, but again, it's only useful for people who are very new to programming. So I made some of these notes, and my first example, actually, I live in the city of Wembley, which is the home of football in the UK. So I decided to use football, but the notes I made here is, sorry?
Can't see your screen, though. Or is it just me?
Yeah.
Okay.
From here.
Wow. Allow. Tell me when you can see it. Okay.
I see it now.
Which screen are you seeing, please? You can see my
Google Colab.
Collab,
good. Good. Today we are just having all sorts of interesting things. So what I talked about, the comparison operators, of course, I've listed them out here. I didn't mention not equal to, but I've put some of these notes so that if you guys want this thing, then it can be reminders of what we've done. So one of the things I have done, I'll just talk through the very simple examples I've used. I said I live in the city of Wembley, which is the home of football in the UK. And I just decided to look at Chelsea and Arsenal. I'm not too big into football. Can you all still hear me, please?
Yes, we can.
Oh, sorry. I'm becoming paranoid because when I feel the connection is...
It's becoming more interactive. So I personally like it.
Yeah, no, I couldn't share my screen before. So yeah, what I've done here is you've learned about variables. This is just a simple way of creating variables. So I created A and B and assigned Chelsea and Arsenal to them. And these are my goal scores for a match. For now, I said they are 3 and 3. So, and the first thing I did was to say, if score A is greater than score B, print Chelsea defeated Arsenal. That makes sense, isn't it?
Yes.
Yep.
It does.
Yeah. Yes. And And what I did here was I was just trying to show you that you can also, compact your if statement in this sort of way. Okay. I've done different things here. I've sort of put it in one line. I've also broken it up this way. All are correct. Now, in this first, this one, I've only tested for if Chelsea defeated Arsenal, isn't it? Now, if this was all I executed, right? If I go and comment, Omo, you are aware that when you put this, that means I've commented off whatever is going on here, right?
I'm sorry, can you repeat that, please?
So when I put this, see the sign I'm putting at the beginning of the sentences?
Yeah.
That makes whatever is after it a comment. It's no longer going to take part in the code, right? So whenever you see things like this inside a code, yeah, they are just comments.
Okay.
Most of the time we use it to put explanatory notes on what we've done. But now I just want to show what I'm make a point with what I've just done here. So what I've done is I've only said, oh, A is Chelsea, B is Arsenal, and they drew. But in my if statement, I said the only thing I'm testing is if score A is greater than score B, right? If I execute this code, what do you think I'm going to get as my printout on the screen? Would you be able to think of something, Omo? Look at what their score is equal, but my condition is saying if score A is greater than score B, that is where I'm asking it to do this. And of course, this is what I said before, that if you put this colon there and you do this, it will indent it for you. Most IDEs will do it automatically. It still means that this code or any other number of codes indented at this level is part of this. But I was saying, this condition I've put together now, what do you think is going to execute? What would it tell us?
So the value you have there that A is equal to B, sorry, is that what you're saying? Like if you put that code, what the answer will be?
No. I said this is what I've put. I said if A is greater than B, do something. And these are my values. This is A, this is B. And I'm asking you, if I execute this, what do you think the answer would be? Would it print this? That's what I'm asking. Would it print this?
No, it's not going to print it, no.
Because it doesn't meet the condition, isn't it?
Yes, that's correct.
Yeah, okay. I know I'm taking it basic, Hugo. I'm making your class very baby class. Yeah, well, I know.
What I lacked before. So for me, this is good.
who was saying that?
It's me, Aziz. I've always learned alone, like self-learning and all that. It's not much interactive like this. But now it's different.
Okay. So Efe, apologies, Efe will be bored out of his... Efe, no, apologies, right? Okay.
I understand.
Just yeah, bear with your brother and your sister. Right. So, but Omo, what could I do to make this computer print this thing for me?
With your values,
what would I do here?
Okay,
with the values, what would I do?
If you put anything more than 3 for score A.
Good. So let's say they score them 13-3, right?
Yeah.
So I'm going to get, I'm going to get that. Thank you. Now, I had this other condition that I commented off, right? And here again, I said, print Chelsea defeated Arsenal is the same thing as above, right? That's exactly the same thing. But I have an else. Now I'm doing two things here. I'm using one single line to do all my if-else statement. I can have it the way I have it here, and I will uncomment this and run it, and it'll be exactly the same thing. Or I can have it here. So I'm saying print this if score A is greater than B, else print Arsenal defeated Chelsea, right?
Right.
So if I execute now, what am I going to get?
You still get Chelsea defeated Arsenal.
Okay, if I make it this way, then what am I going to get?
Okay, then Arsenal defeated Chelsea.
Yep. Yep. But notice that if I now say they drew, what will happen to this? I've actually put it here. I said I'm missing the condition for a draw, right?
Right.
All I'm bringing out with what I'm doing is that you need to actually be very explicit in telling the computer what to do. Okay. So if I execute this, it's actually not telling me the right thing. Oh, sorry. Maybe it's executing. No, it's telling me Arsenal defeated Chelsea. And that's because I said else. Else means if this condition is not true, then this is true, right? That is what else means. But in actual fact, this is actually not factual, is it? Because Arsenal didn't defeat Chelsea, did it?
No.
Oh.
So you have to be very mindful when you're doing things like this. So I deliberately did this because by saying if score A is greater than B, say Chelsea defeated Arsenal, else say Arsenal defeated Chelsea. But no, that's not true because they could have drawn. This would be correct and fine if I had this, right? If I had this, then that's okay because Arsenal defeated Chelsea. But if it's a draw, no, it's going to tell me Arsenal defeated Chelsea because the else is always a catch-all for what didn't execute in an if. Okay? If is it making sense? Oh, sorry, Omo.
Yes, it's making sense.
And apologies again, Ugo. I'm just doing a baby class. I think I'm happy to do this. If it's too baby
It's
for
fine.
you,
It's fine. It's fine.
I keep apologizing because this is my style of teaching. I can teach babies programming. So if you see what I've done with this other condition here, can you see I've actually made sure that I've caught everything possible. So I have score A being greater than score B. I have score A being equal to score B before I then have an else. Yeah? Because that's the only three conditions I can have, isn't it?
Yeah.
Hello, people, answer
Right.
me. So, yeah, it's either it's either A is greater than B or B is greater than A or they're equal. That's all. That's the only three conditions. So when you're doing your programming, you must be careful that you don't do something like this, right? And Omo, if this was money, right? Well, some people might not be very, very happy with you if you award it to them because you put a sweeping if. Does that make sense?
Yeah.
I'm using football, it doesn't matter, but if it was about balances and stuff and all of that, you have to be mindful and be very careful that you put in every single condition that is possible and cater for all of them. Right?
Right.
Now, when it comes to the style of programming, so I've done this, which is block. And if I evaluate this, if I was to run this now, let me comment this off again. If I was to run this again, yeah. So this is, remember, I still left this on, right? So can you see? It's telling me this one. Chelsea drew with Arsenal, isn't it? Which is correct. That's this condition. So this is not right for when it's a draw. But when it's, when it's a draw, this is a better, it has got every condition I want. Now, why is it important? Why am I going over this? Because I've seen sometimes, people do not understand that you need to be very, very detailed in specifying your conditions. And in one of the lessons you did last time, I heard someone mention the pseudocode. Ugo, I'm right, aren't I? Has it gone away?
Yes, you are.
I'm sorry. I want to be sure I'm still online and people are listening. So what the pseudocode? I'm of the old school of programming. And old school in the sense that it's been a while. I've been in this thing, and we are of the group that actually made pseudocode in use, where nobody would allow you to start coding until you've done your pseudocode and it's been approved. That was the style of programming in those days. The managers will read your pseudocode and make sure, because computer resources were very expensive. So I started off working on the mainframe. So to power it on for you to write your code, you had to be sure that you've got all your logic intact. So you would actually do your pseudocode, people will read it through, approve it before you start coding. That was the style at the time. So what happens with the pseudocode is that it will allow you, and pseudocode, there is a specific syntax. There was a specific syntax for writing pseudocode and drawing flow diagrams. Again, I'm of that old school where we had to draw the flow diagrams for the program before you ever got to start programming, because again, computing resource was quite expensive. So you would draw your flows, and for every decision, when you have the triangle, I don't know if you guys know anything about, the diamond. Are you familiar with the diamond, flow diagrams when you're doing them? Is anybody familiar with UMLs or any of those things where you have to make decisions and branch out?
And no, for now, we've not taught the class flowcharts.
No, I'm asking if they're familiar with it. I'm even asking.
Okay.
I'm just
Okay.
asking. Yeah.
All
Yeah.
right.
So, but flowcharts is, again, it's like putting it down in some pictorial way, but it allows you to make sure you've covered every single possible condition before you start programming. So I'm just putting it out there because, you might have seen it or done it elsewhere. But the flow diagram and the pseudocode were things that were sort of basic to when I started programming. And what you do with those things is, because for every decision you make, the managers will ask you, so what if this happens? You have to evidence that you've actually put that specific condition in a place and given it whatever execution it needed to do, right? Ugo, when are we supposed to stop?
We're supposed to stop at 3.
Right. Okay. And I'm here just being very, very detailed on the if. I had a few things we needed to cover, but again, I'm happy if you get the concepts, get the understanding. I'm happy to come again. If I don't bore you all to death, I'm happy to come again and take the other iterations. But I'm hopeful that by the time we finish with this, if, else if, elif wouldn't confuse you or be anything to worry about. Now I've tried to put together this other part, and let me go into it and explain what is going on here. The simple thing going on here is that I've just added the elif, which is I've put notes at the beginning. Where did I put my notes? Yeah, I put it here. You can have just an if statement like this. This is a standalone if statement with no else. But you can also have if statements with as many elifs as you want, elif being the short form of else if, and then terminate it with an else. And here you can have as many of them as you like. There is a, I tried to recreate, I tried to recreate the number guess game last night. I didn't use exactly what Gert used, but I tried to recreate it and I actually did something that was had a bit more. Yeah, this one had a bit more of the else if going on here. Now, you can have as many of the elifs, and this is what I was talking about. When you have this if, this will execute as one. This, what I've highlighted, will execute as one. This elif is if this is not true, it will, if it just looks and the player is not computer. I'm sure we understand what this is, right? Omo, you understand what this double equal sign is?
Yes, I believe.
Omo, are you there?
Sorry, I was trying to get myself off mute. No, not the double equal sign.
No. Okay, who can help her? Let me not answer. Aziz or Efe, do you want to explain what that means?
For me, it means it is the same thing. Like a player is the same as computer.
So it's actually, yeah, you're right. It's almost like an equal sign, but here we use the equal sign when we are assigning variables and stuff, right? Or when we are doing a mathematical operation, we use the equal sign, the regular equal sign. Or Ugo, do you want to explain this? Let me just take a drink of water. This, if you're there.
Yeah, I'm here. Okay, so Omo, this is how it works. In Python, everything has to begin with a variable. Every instruction you have to give to the computer. A variable is like I was explaining in the office hours some weeks back. A variable is like a noun in the sense that there's practically nothing you can describe in English language without using a noun. So if you want to describe an animal, it has to be a noun. If you want to describe a person, it's a noun. You have to. So that's basically how a variable is. So
You're just
that's
naming something. You're just
yes, you're naming something.
giving something a name.
Exactly.
It's almost like, yeah, you're giving something a name. Depending on whatever that something is, we will get to understand later. But what, and these are all variables up here, right? Okay. So everything here, this is what he means by it's a name. So you choose.
So when you want to tell a computer this is a boy, you're going to tell the computer boy equals to maybe Emeka.
Okay.
Then if you want to tell the computer this is like you want to tell the computer like Michael is a man, you just say man equals Michael. So that way the computer knows, okay, you're telling me Michael is a man. So because
let me explain again.
Yeah,
sorry,
okay,
Ugo.
go ahead.
So what you've just said now, just so she understands it. So you say man equals Michael, right? Because there are many possibilities of men. So man can be Ugo, Michael, Aziz, Efe. Does that make sense?
Yeah.
But at that particular time, you're telling the computer that the man you're interested in is Michael. And just like what we did with the score, remember, this is a variable. Mm-hmm. These are the values I assign to it. So this is how you assign variables, values to a variable, right?
Right.
So I'm saying that score A, and a lot of times you try to do it in, so it makes some meaning to you, so that when you see some other times. So because I said A is Chelsea and B is Arsenal, I said score A, which is A, score for Chelsea. I could have written score underscore Chelsea, but I just decided to use this. Now, this is like that mic, okay?
Okay.
And why I said man, you're using man as a variable, and Mike is something you are assigning to it. It's like an instance of a man or an example of a man, right?
Right.
Because there are many examples you could use. So man can be Michael or Efe or Ugo. And like we did here, and I was able to put 13 as the score. I can put any value I like here. Okay? Yeah. Okay, Ugo, I'll leave you to explain a bit more.
Hello, ma. Hello, Ngozi.
Hello? Yeah?
Okay, so I'm thinking it will be best for her to understand when you use single equals to and double. So I think
Yeah,
she will
that's what
get
I'm saying. Now I'm going
better.
to, that's why I said explain that double equal sign, because I just interrupted to use the example of something we had already done about the variable. So go ahead with the double equal sign.
Okay, so for when you are telling the computer that what you want is a variable, you use a single equal sign. But now, because that single equal sign, some will always say the computer is very dumb, the computer doesn't know anything. And you have to treat the computer like the most dumbest device that has ever been manufactured. So the moment you have used that equal sign to create a variable, if you try to use that equal sign again, like, no, but you just told me that man equals to Michael. So why are you not telling me, so in order to not confuse the computer, whenever we want to tell the computer about a variable, we use equals to, one single equal to. But whenever we want to tell a computer to evaluate whether something is equal to something, then we use double signs. So we use one sign when we're telling the computer one equal sign about a variable. We're just telling the computer, hey, man is Michael and stuff like that. But whenever we want the computer to evaluate equality to say, okay, are these guys,
Are they the same?
Yeah, then we will now have to use double equal sign.
Okay. All right. I get that now. Thank you.
I want you to walk away today when you look at a program. I want it to make sense.
Yeah.
Okay. If it's at the expense of your brothers, I have begged them to bear with us today. So, and so what I was talking about, when you do this and you put this colon at the end, automatically it will just indent whatever you're doing. Any other thing you type, it will actually indent for you if you're using like this place or any ID to type. Most of them would do it. It will just indent it. So now this will execute as one. Okay.
Okay.
But the way computer passes control inside the if statement is, it says if player equals computer. Okay. If the player, this is a game, so the computer is playing against me, for instance. If the person playing is a computer, yeah. If it's not the computer, so if it's the computer, to go ahead and do this. But if it's not the computer, it will just go here. Does that make sense? Amo?
Oh, sorry. Yes, it makes sense.
So that's the way you pass the control. So the computer, once it looks and this is not true, it will move on. Okay. If it looks and this is true, then it will execute what is here. But if it looks and this is not true, it will not bother going into here. It will just move on to this place. Because these are all indented at the same level. So it will be passing control. If this is true, to go inside it. If it's not true, to go to the next one. If this is true, to go inside here and execute this. Again, the same thing. If this is true, it will go here. If this is not true, to go here. But if this one is not true at all, this elif, the first one, it will just move on to this.
Okay.
If this one is true, again, that's the way it will pass control. But if this is not true, it will move on to this. Right? And that's how it passes control to the end. So if none of them is true, it will come here and then that will be the end. Right?
Right.
Okay. So Yeah, so that is how you use the if to pass control in your program. So when it's executing again, as I said, here, if this is true, it will do this. We did it here. I put it on the same line. I put it here just so it's the same thing I've just explained now. If score A is the same as score B, it will do this. But if the score is not greater than this, it won't bother going in here. It will just go here, right? And once it looks and this condition is not true, it will go here to the else. And when it comes here and it finds there's nothing else to execute, that's the end.